For a real number x, we denote by floor x, the largest integer less than or equal to x. Let f of x equal to x over 2 minus the floor of x over 2. The smallest number of equal width strips for which the trapezium rule produces an overestimate for the integral from 0 to 5 of f of x dx is 2, 3, 4, 5, or it never produces an overestimate. Okay. My instinct here is that it'll never produce an overestimate. What is this function? Actually, that might be wrong. So what does this function look like? It's going to be like a sawtooth function, right? It grows linearly with x, but then when x crosses over every half integer, it drops. So I think plotting this function is going to be the best way to see what the answer is. I believe this function is always non-negative. So of course we're only interested in the function up to 5. Okay. So between 0 and 0.5, the function is linear. No, between 0 and 2. Yeah. Between 0 and 2, the function is linear. And when x is equal to 2, this function is equal to 1. Right? And you can check this by substituting some values of x. If x is equal to 1, f of x is equal to 1 over 2 minus the floor of 1 over 2, but the floor of 1 over 2 is 0. So over there. And then I guess we have a, it won't really matter, but we have an open piece there and a solid piece there. And then again, we grow linearly like that, and we'll grow linearly like that. Okay. The smallest number of equal width strips for which the trapezium rule produces an overestimate of the integral. So if we use an overestimate, yeah, so I don't, Well, I'm going to draw these here because this will help in visualizing what the area, what the actual integral is. You know, we could just compute the area of these triangles and that would give us the full integral. If we use two strips, if I draw this in green, if we use two strips, then the trapezium rule would be the area under that curve, which is clearly going to be an underestimate. So let's ignore that. If we use three strips, 5 over 3. It's a little bit less than 2, right? So you'll have one there and one there. Maybe this would give us an overestimate. Right? The area underneath that curve might be an overestimate. We could write down exactly what the trapezoid rule or trapezium rule gives in this case. Is it worth actually just writing that out? I mean, let me just, I want to kind of continue this just geometrically and see if we can figure this out. So the answer, that looks like it could be an overestimate. Of course, my drawing is not to scale. Maybe it's worth actually computing the integral and then actually computing what the rule gives us for each of these number of subdivisions. Yeah, let me do that actually, rather than just trying to visually estimate all this stuff. Okay, so the actual integral from 0 to 5 of f of x dx is 2 over 2 times 2 plus 1 over 4 so that's 9 over 4, which is about 2.25. So that's just the area of these three triangles. Okay, let's compute T2. So T2, it's called the trapezium rule, but yeah, well, I guess some of them will be trapezoids. This is 2.5 times 0.25 divided by 2. And then we have to multiply by 2 because there will be two triangles like this, right? This length is 2.5. That's this. The height of each of these triangles is 1 over 4 divided by 2, but then multiply by 2. Okay, so this is, I don't know, 2.5 over 4, whatever that happens to be. It's clearly a lot less than that. So this is not an overestimate. T3, okay. Let's try and figure out. So we have f of 5 over 3 let's write this as f of 5 over 3 times 5 over 6. That's the area of that first triangle to the left. Then we have to take an average of these two values plus f of 5 over 3 plus f of 10 over 3 divided by 2 times 5 over 3, well, 5 over 6, really. So that's the area of this inner trapezoid. And then we have f of 10 over 3 times 5 over 6. And that'll be the area of that triangle. So let's figure out what that number is. F of 5 over 3 is, well, that'll just be 5 over 6, right? So here we have 25 over 36 plus, okay, f of 5 over 3 is 5 over 6 plus f of 10 over 3. So it'll be 10 over 6, is that, 10 over 6 minus the integer part of 10 over 6. So it's 10 over 6 minus 1, so that's 4 over 6. And f of 10 over 3 is, like we said, 4 over 6 times 5 over 6, okay. 25 over 36 plus 9 over 6, 9 over 12 times 5 over 6 plus 20 over 36. So I've got 45 over 36 plus 9 over 12 is 3 over 4, 15 over 24. Yeesh. I'm sure a lot of stuff here can cancel, can it, right? 15 over 12 plus 5 over 8. 5 over 4 plus 5 over 8. 10 plus 5 over 8, so 15 over 8, which is a little bit less than 2. So that's not an overestimate, right? It's still an underestimate. Okay? I mean, a whole bunch of arithmetic going in here, right? But okay, so you know what? I'm seeing now for sure that the answer cannot be E. There will be an overestimate, and there will certainly be an overestimate using 5 equally sized subscripts, because with 5 subscripts, the rule would, the function you would then end up integrating is, so that's one substrip, and then you compute this, but then you would connect this point to here. Wait, no you wouldn't, because it's a solid, oh my. Yeah, you would go like that. Okay, well, let's try it for 4. Is there a way we can see easily that with 4 substrips it won't give an overestimate? Let's draw approximately what everything looks like. So 1.25, 2.5, 3.75, and 5. Okay, so we have that, and that. This looks like it's probably still an underestimate. But I'm not positive. You know, this part here could be, you know, this is clearly in total, that's clearly an underestimate. You know, this part is missing, and that's, yeah, you know what, I'm just gonna evaluate it, although we don't need to do the whole maybe we should do the whole thing though. You know, going through this, I really don't think this is a very interesting problem. Unless there's like something really clever you can do. Certainly the way I'm solving this does not make this a very interesting problem. Okay. Well, T4 is going to be f of 1.25 times 1.25 over 2 plus f of 1.25 plus f of 2.5 divided by 2 times 1.25 over 2 plus f of 2.5 plus f of 3.75 over 2 times 1.25 over 2 plus f of 3.75 times 1.25 over 2. Okay, well, let's take out the 1.25 over 2 from everything. So I have 2f of 1.25 plus 2f of 2.5 plus 2f of 3.75. Okay, so 1.25 times f of 1.25. Well, 1.25 over 2 is 0.625 plus, okay, f of 2.5 is 0.25 and f of 3.75 So this will give us 0.875. Is that right? Yeah, okay, so this is 12.5 higher than a half. This is 12.5 lower than 1. Okay. And let's add these up and hopefully not make any mistakes. We've got 5 over 4 times 7 over 4, which is 35 over 16, which is, so we want to compare to 2.25, right? Well, 2.25 is equal to 9 over 4, which is equal to 36 over 16. So this is still an underestimate. So the answer is my first instinct, that this will never overestimate the integral. I mean, I could see for other bounds of integration, you know, if this were not an integer, maybe there are times when you get like a trapezoid up here like this, and then another trapezoid across like that, and then another one down like to there or something. But, you know, as it's given, with the options we have by the process of elimination, we've directly checked for 2, 3, and 4. The answer cannot be 5, because like I said, for 5, the area we would be computing is the area under those triangles, which is clearly an underestimate. Yeah, there's got to be like a nicer way of seeing what the answer is here. Maybe I shouldn't have done any of this geometrical thing, and maybe I should have just skipped instantly to the formula for the trapezoid rule, because, you know, we do have a lot of cancellations. It was pretty easy to work that out. But my first instinct was to try and work it out. Well, my first instinct after the correct answer was that we should try and work it out geometrically. Yeah, don't really have much more to say about this one, but if I think of something, I'll put it down in the description. Thanks for watching.